What's up everybody, I'm JD from Affinity Collective Tech, and today we're going to be discussing a little thing called RAID. Many of you might be asking, what is RAID? RAID, or redundant array of independent disks, takes multiple drives and combines them into a single logical drive for data redundancy, increase in the drive's performance, or both. What type of RAID you should use really depends on your own situation. RAID comes in many different variants. The most common RAIDs are 0, 1, 5, and 10, and these are the ones we're going to be going over today. In a RAID 0, the size of the volume is dependent on the sum of all the drives put together. RAID 0 is most commonly used in a gaming PC setup or whenever you want high performance. This is because it increases the actual speed of the drive array. It does this by striping together the drives. In other words, the data is all split among the drives in the array. To help explain a bit more, imagine you are playing Payday 2 with your friend. If you have 10 bags of money you need to move, it'll be faster if you move them together rather than moving it yourself. When you go to access that file, both drives will start to read the same file, increasing the speed of the read by allowing one of the drives to actually read ahead. If one drive fails, you will lose the entire RAID volume, while also decreasing the possibilities of data recovery. RAID 1 utilizes data mirroring. During data mirroring, the data is written to 2 or more drives. This allows any drive in the array to access the data when requested. It also creates a redundant array, allowing one of the drives to fail and still allowing you to retain all the data. The size of the volume is only as big as the smallest drive in the array. For example, if you have a 500 GB and a 1 TB drive in your RAID 1, your total volume will only be 500 GB. RAID 1 is a cheap and easy way to set up file redundancy on critical data. Paired with something like an external hard drive as a separate backup location, you can keep your data safe for a low cost. RAID 5 requires the use of at least 3 drives and consists of block level striping along with the distributed parity. RAID 5 requires the use of at least 3 drives and consists of block level striping along with distributed parity. First, let's go over what a parity is. A parity is a drive used in RAID to provide fault tolerance if it fails. So distributed parity is when that backup data is split among the drives in the array. RAID 10 or RAID 1 plus 0 needs at the very least 4 drives. This is a combination of both 0 and 1. It will increase speeds and redundancy through striping and mirroring. It writes to the drives the same way RAID 0 does, but it has a second set that builds in redundancy. This provides RAID 0 type speeds partnered with RAID 1 redundancy. When taking a closer look at it, 2 separate RAID 1 arrays are striped together using RAID 0. This is called a nested RAID. Now all this sounds great, right? Well, there is a major drawback. Since all the data is written twice, your effective storage is cut in half. If you have 4 1 TB hard drives totaling 4 TB, when you put those in RAID 10, you can only use 2 TB of storage. So keep that in mind if you are thinking about implementing RAID 10. Before you start RAIDing your drives, you need to know what you want them to do. Each situation may call for a different method. Cost, data redundancy, and performance all play factors into the final decision. Remember that although RAID can provide data redundancy, it is always a good idea to have periodic backups made in the case of a physical failure. So with that, we hope you guys enjoyed. Let us know in the comments below what kind of RAID setups you guys have. While you're down there, be sure to drop us a like and subscribe to help support the channel. As always, see you guys next time.